All right. Well, hi, everyone. Brad Kaiser just jumped into the chat here. So, Brad, really appreciate the time and joining us for the inaugural webcast here. How you doing today?
Yeah. Thank you,
Awesome.
Brian. Thanks for inviting me.
Yeah, no, we really appreciate your time. So, before we dive in here, obviously both of us are kind of working from home. I'm based out of my apartment for the indefinite time here. I'm out of Chicago, Illinois. We've got our stay-at-home order for at least another month, but it's kind of encouraging to see plants starting to open back up and people are starting to go back to work. So I'm sure you'd echo this, Brad, but I think we're both excited to kind of get back out there into the action and visiting plants and customers and seeing it out there. But how
Absolutely.
about we'll start with you here. Can you tell us where you're sitting at today and walk us through what a typical day looks like for you?
Sure. I'm in my home near Tampa, Florida. That's my residence. And so my typical day, I try to keep a routine, in this environment. You got to keep your wits about you and you got to keep calm. And so I've kind of developed a routine, get up and do some stretching and do some, try to keep active. You can't sit all day, but it's very easy to do so.
Yep.
I find myself doing a lot of web meetings and demos, and which has actually kind of been nice. It pushed us into a new kind of era where these web meetings are very effective.
Sure.
And I don't think we completely utilized them before, but now it's kind of forced our hand, and it's been good. It's a good way to stay in touch, and things like this are a great way to communicate with our customers, and hopefully soon we're back to normal or whatever normal will be.
Yep.
And so a lot less travel for me, that's for sure, which is nice.
Yeah, so is that pretty typical, Brad? Do you get out into the plant setting a lot, or do you drive a lot of your business from home there?
Yeah, most of it, in automation, you really have to walk the plant, understand the workflows, see their processes, ask in-depth questions. It's very hard to do that from, a FaceTime or a web meeting.
Yep.
Get to the bottom of it. Really seeing how the people flow in and out of the factory is vitally important. So that is a lot of my work, is travel out to the customer site and talk with them, talk with the different levels of management, all of the different people that are going to have a say in this project. So to guide it through to a successful conclusion, in the past, certainly walking the plant floors and being on site has been important. We'll see how we adapt to that with the new normal coming up.
Yep, absolutely. So let's jump right into it with Creaform. Can you kind of walk us through what your guys' core business is?
Yeah, so Creaform is based out of Quebec City, or near Quebec City, and they develop and manufacture 3D laser scanning products for product development, and as of recent, quality inspection is the primary industry that we go after. The systems that are built by Creaform are a little bit unique in the industry, and that they're very portable. And so being able to take them out to the shop floor, throw a part on a workbench next to a machine is something that we do really well. We have a technology called, basically dynamic tracking of the part and the surrounding environment, which allows us to deal with vibrations. It allows us to just really get up close as to the line as needed, and deal with the vibrations and all of the other environmental things that kind of usually would mess up your data in a metrology setting. So our systems don't have to be isolated in a quality lab.
Got it.
And so in my role as the sales manager for automated quality control systems, we leverage that same technology, this dynamic tracking, to be able to put our scanning systems right next to a stamping press, for an example, or right next to the machines that are actually making the product, so we can get a quicker turnaround on that inspection report and get that data back as quickly as possible. So basically leveraging that technology across our whole platform of portable and while maintaining accuracy, and we've pushed that into automation. And when we talk a little bit later about some things that you and I are working together on, that dynamic tracking functionality lends itself really well to flexibility and able to adapt to these environmental vibrations and changes that happen on the plant floor.
Yeah, so that's kind of a good lead in, and you mentioned, being portable and easy to move around a plant. Is that pretty typical, or what are some other technologies that you guys integrate these scanners with?
Well, sure, we can integrate, obviously, so mounting it on a robot, whether that be a traditional industrial robot or a collaborative robot, is something that we do. Obviously using a turntable, things of that nature can be integrated into as well to provide the additional access. And with the other technologies, of course, software has come a long ways with, either our software or third-party software to do those inspection reports, the trend analysis, the track and trace, all of that kind of functionality is really, really important. And then, something that I'm excited to work with you on is this AGV project.
Yep.
Where basically the scan head would be mounted on a fixed robot, but the ability to move into the part on a fixture can move into the inspection cell. And yeah, you're going to play it here. So this is something that we've been working on here. This has kind of been a vision of mine for quite a while. I think it really lends itself to this wave of flexible manufacturing. So basically on Eckhart's AGV here, on that companion rack, brings it in a fixed location. Again, with our dynamic tracking, you can see the C-track kind of closest to us here, tracks the environment, would be tracking positional targets that are placed on that rack. And so as the part comes in, it gets scanned, communicates with the robot that it's a good part, and it goes off on its way. The next part comes in, sends a signal to the robot to call up the certain robot program. The inspection program would all be automated within this functionality as well. The robot goes about scanning the surface and all of the different features that we call out in the robot program and the inspection report. And then we get a pass or fail. For the robot, it's a pass or fail, and the AGV would take it off to a rework station if it didn't fail certain parameters. This highly flexible, highly mobile movement of your parts really lends itself to being something you can do close to the manufacturing process. And really one of the problems this solves is the bottleneck that other CMMs or other inspection systems that have to be isolated in a quality lab. Ours can be out there on the plant floor, and having this movable cart come in and out of the inspection cell is really powerful. So this is something that we've been putting together and really excited to work with you guys on.
Yeah, and so obviously you guys have the end-of-arm tooling here. Do you want to touch on the other pieces of hardware that you guys have that's featured in here?
Yeah, so on the right-hand side, up in the kind of to the right, there's the C-track. So that's our dynamic tracking device. So that's tracking the end-of-arm tooling on there. So as this moves around, we have eliminated all of the positional accuracy, or we're not getting any positional accuracy from the robot or necessarily the AGV itself. Those typically aren't accurate enough for the accuracy specs that we go for. So with our dynamic tracking setup, we're tracking the head and we're tracking the cart independent of the location of where the robot thinks it is. This same technology can be used for any kind of end-of-arm tooling tracking, maybe developing that out for more precision drilling and tapping, or robot calibrations and those kind of things as well.
Got it. Appreciate the overview there. Very helpful. Jump back in here. Stop share. Can you talk about the product development pipeline for Creaform and anything you guys might be working on?
Yeah, our R&D facility is up in Lévis in Quebec. They're very tight-lipped on the new products and development. You know, the competition is extreme right now, and so slipping things out too early is kind of detrimental. But we do have a product launch planned near the end of June, and as always, our R&D team is pushing the edges and you know, always trying to make things, you know, faster, higher resolution, more accurate, data acquisition, you know, being better able to scan shiny surfaces. You know, the portability is one of our mantras at Creaform. So I'm sure whatever they have planned is going to be, you know, push that next level of metrology forward. And so stay tuned. We'll have a lot more coming out probably the end of June.
Good stuff.
Yeah.
How about a unique part or application that you can maybe share with the audience here?
Yeah, so we've already touched on AGVs. Super excited about that.
Yep.
But other applications, you know, in my role, it's fun because I get to talk to robotic startup companies, integrators, you know, and then of course just end customers trying to develop out new techniques. The applications that are really kind of forefront and that I get asked the most about, one I kind of touched on is that end of arm tooling tracking. Mm-hmm. So, you know, the robot goes to a location based on the coordinates that you gave it, but we can precisely tell the robot exactly where it's at. Merging those two technologies, so driving a robot drives to a certain position, and then within our technology, we can track that and actually tell it where it is so that it can correct its position. So doing some precision drilling and tapping, that kind of functionality, as well as adaptive manufacturing. I think that this is what people are calling it. But it's basically when we get our scan data, we can pull out a report and we can do a color map, we can extract certain features. And so what that allows us to do is to send this data, whether it's XYZ, IJK, coordinates, whatever that might be, to a robot downstream so that it can potentially grind and deburr a high spot off of a particular part. That's kind of important for, you know, refurbishment or a lot of castings, things like that, or even with additive manufacturing and printing. It's not so much correction downstream, but they can also send information upstream so that if you're trending towards something being out of tolerance, potentially you can send data upstream in that process to kind of correct some of those positions, maybe even to a laser cutter, or it could be a CNC milling machine, things like that, to correct the problem before it becomes out of tolerance. So as it's going towards marginal, maybe it corrects its behavior. A lot of people working on that solution. I get a lot of requests for that kind of information. And because we have so much data that we have captured, this is the kind of information that we can extract from that, kind of pushing the way people are thinking about automation and how they can react to defective parts.
Interesting to hear it from your end on the, you know, inspection and actually finding those errors. As a robotics integrator, it's a hot area for us. Material removal, you mentioned grinding, deburring, big hot spots for automation right now, definitely. How about any recent projects that you've worked on that you might be proud of and that you can share with us?
Yeah, some recent projects. I can't really share the customer, but in the heavy industrial industry, very, very large parts, big welded parts, where alignments and things like that, pivot points become very, very important. Mm-hmm. And with the traditional type of maybe probing or you know, articulated, you know, scanners attached to articulated arms, sure, can be very cumbersome on those big pieces of equipment. And so we worked with them very closely to install a automation cell that allows them to be right at the end of their weld line. And so as these parts come out of the weld line, they go right onto a turntable. The robot gives it 100% scan. We're looking at the weldments. We're looking at alignments, perpendicularity, and different hole alignments, things like that, so that we can ensure that it's a proper part before it goes to paint. Their procedure before this was it went to paint, and then it went to assembly, and then if a part didn't fit, well, then there's a whole bunch of rework and scrap costs that were incurred too far downstream.
Yep.
And that's one of the exciting things about our technology and our ability to adapt to the vibrations close to the machines, that we can catch these defects early on, so it reduces the cost incurred downstream as all these other processes have happened. So this project we've been working on it for quite a while. It's coming to the end now. There's a couple of stages involved in it, but it's really helped them to, as they scan this right next to their line, they're watching the trend analysis. So, are these fixtures and welding fixtures getting out of alignment? We can pick that up very quickly. We can track, the time of day that the weld was done, different features, and they've actually been able to go upstream and correct some of these fixtures almost immediately after the first defect was found, rather than making 5, 10, 20 parts before they caught that downstream. So really exciting project, a great customer, and exciting to kind of lean forward on that automation and that trending and analysis being almost immediate.
Yeah, I have to imagine that has to be one of your biggest selling points, is kind of preventing all of that rework downstream and all that cost that really just adds up.
Yeah, absolutely.
So how about, let's talk about the weird times and era that we're in right now with COVID-19 and a lot of plants being shut down, workers being furloughed. How has it all affected your core customer base and how they think about automation?
Yeah, and our core customer base is automotive, aerospace, heavy industrial, probably the top three. Mm-hmm. Of course, they're all been affected. The automotive, very, who knows how that restart looks and what that means downstream to the suppliers. We work with the large manufacturers as well as all of their suppliers. And it's really created a ripple effect all the way through. Mm-hmm. Of course, I mean, it's not telling you anything new, but it's. I think it's going to, in the automation. My day-to-day has still been very busy. The engineers that are at home, they're still working on the projects that were started. The funding of those projects is probably a little more questionable at the moment, depending upon. Sure. Aerospace took a pretty good hit with this, and then also the 737 MAX being grounded for a while. That sent some ripples through the supply chain. But we're dealing with it. Everybody is kind of is regrouping. I think automation in the long term has a lot of relevance. The variability that is being seen right now with, can workers show up? Do we have to scan them at the door? I talked to one manufacturer recently that it's taking 30 to 45 minutes prior to their shift just to get people in the door. And so funding is obviously a problem with automation, but the demand is going to be there. So it just takes the variability out of a lot of these processes, and so it's something that's going to be moving forward. The automation industry is going to be okay. The rest of these industries are going to be okay, but it is certainly going to look different. I don't have a crystal ball. I don't know what that different looks like, but it will be different. I know that much.
Yeah, you mentioned aerospace. We were on a call. We were part of an association with the industry, and they mentioned 2023, 2024 is best case for seeing just commercial airline travel back to, what they would consider normal traveling for, 2019. Yeah. A lot of people cutting back on travel, and a lot of those planes just not racking up typical mileage. So
Mm-hmm.
it'll be interesting.
Yeah. Yeah.
How about any industry trends that you guys see that are happening out there right now?
We talked about the adaptive manufacturing. That's one part of it. Flexible manufacturing, the AGVs, the collaborative robots, collaborative work cells, robotic collision avoidance, all of these kind of things. A lot of startup companies really getting creative about how they're using artificial intelligence. They're using it for robotic welding. I've seen some applications for robotic forging. Inspection analysis is using artificial intelligence. So those big things, but the flexibility in manufacturing, I think, is going to be probably one of the bigger drivers of, the biggest trends that I see out there. Just being able to adapt quickly to changing things. The high volume parts have mostly been automated. The stuff, in your industry, things that were easy to automate have already been done.
Yep.
And so now we're getting to the part where it's the low-hanging fruit for automation isn't necessarily there. It isn't just a slam dunk. You have to really be creative in the industry to be able to, one, give the customers what they want, and then figure out a way to produce those assemblies and the parts and the components and all of that stuff. It's really going to take some creativity on the integrator's part to, give them what they need, and that need is going to change very rapidly. Mm-hmm. The next 5 to 10 years, just in general, is going to be amazing with the amount of change, and this COVID experience is accelerating all of that. The remote work, the flexibility, the remote logins, all of that kind of stuff is going to be demanded. But being able to be flexible in your manufacturing will allow customers to take on different products, maybe not in their core competency. We saw Ford pivot and start making masks and ventilators. They went from making cars to making masks in a matter of a couple of weeks. I think there was a lot of hands-on, and they probably didn't have the automation behind it. Maybe in some respects they did, but they had to pivot. And so I think pivoting to new products, new ways in which to manufacture things is a big trend that I see, and I think that's a big, demand going forward.
Yeah, I think you nailed it. And going back to your statement there on the American factory, what do you think it looks like in the next 5 to 10 years? Is there anything that's going to be drastically different? And what's your thought there?
Well, the interconnectivity of the machines is going to be, that's really kind of already here. Machines can communicate with each other quite dynamically, really. But it's really going to, part presence, part absence, good part, bad part, that stuff has all been done already. So I think the intercommunication of these machines, building upon artificial intelligence, building upon, communication links that may be global, centrally located servers and things like that may become more decentralized, maybe in sort of a blockchain fashion or something along those lines. But the interconnectivity of a factory in China and a factory in Kentucky is going to be vital. And we want these machines learning from one another. If they're doing basically the same process, the one machine should be learning from another machine. So what these machines are talking about is kind of the interesting thing to me. In our field, we're very interested in, just like what we talked about, sending this, extracting data from a full surface scan. So we know full dimensional accuracy of this entire part, and maybe one machining process. Maybe it was heat related that caused the defect. Maybe it was a pressure or some sort of gauging, but when you can catch that so quickly, those machines can communicate intercompany, intercontinental, really, which is pretty amazing. So I think it's going to be so much a combination of everything. I don't think any one company is going to develop the solution. I think in a large part, it's going to be integrators like yourself at Eckhart, putting all of these systems together. I'm always so impressed. Creaform doesn't do the integration of our own systems. We rely on groups like Eckhart to install our systems, as an end-of-arm tool. But companies like Eckhart are going to have to bring in all of these different technologies, be skilled in artificial intelligence and machine learning and machine communication and all of that, to put the whole package together for the customer. That's the big trend. I think, I have so much respect for integrators because it's a tough business. Customers don't want to spend a lot of money on these systems, but yet they want the world. And you can talk more about that than I can, but they want all of these things done and done quickly and for less money. So that's the hard part. Almost anything now can be done, but is the customer willing to spend the money to get these things, to put all of these technologies together? The great part of this is that the cost of these technologies are going to come down. The ability to integrate them all together is going to come down. The usability of it is going to become quite user friendly. But putting these packages all together is going to be a really tough job. Mm-hmm. But it's going to be critical, and it's going to be the integrators that do it. The factories, the manufacturing engineers, and them, they don't do these big projects. They hire the integrators to do it, and so combining these technologies is going to be the key to this factory of the future. But it's going to be exciting. 5 to 10 years from now, I'm an eternal optimist, so I think it's going to be exciting, and I like to see the disruption and the new developments and how people adapt to that. It's going to be exciting.
Yep. Well, we appreciate it, Brad. I think you kind of nailed it talking about the integrator software partners, just like we have, and that's why we value partnerships so much, like the one that we have. And for you just to take the time here and share more about your technology, we really appreciate it.
Yeah, absolutely. Well, thanks for having us on, and we'll be working together in the future, and maybe you'll post that video online of the AGV cell. It's going to be helpful, and I really appreciate you getting me on here and letting me talk for a bit.
Thanks, Brad. We appreciate it. We'll talk to you soon.
All right. Absolutely.
All right. Bye.